Here I am with the latest smokehouse. I'm doing a bunch of testing. I'm using direct power 5.75 to the heater directly. That goes through some bunch of wires. It ends up being 5.67 at the heater. This is a direct link to a thermistor that gives me 2.39 ohms, but that correlates to 90 degrees, and that's all on the top surface. If you look down into the cavity, you may see some smoke coming out. That means the chamber is full of smoke. So I'm going to give it one puff, and I'm going to give it another one. There you go. There you got to see the full view of that. So we're getting puffs, and it's pretty strong. And I got the voltage is about 2 volts on the fan. So you're going to get a pretty good puff. And it's going to stay pretty nice. What I need to worry about is allowing the wick to take place when the oils are evaporated, they get replaced, and how fast and all that. If I leave it on, you can see the smoke dissipates quite a bit. And if I let it sit for a moment, it comes back. If I sit for longer than a moment, it comes back thicker. And if you look down in there now, you'll see no smoke is piled up yet. So there is no reservoir of smoke in the chamber. So it kind of runs out of smoke. I may be low. I've been doing this all day. But I will reload the smoke and see what's going on. But what we're doing here, we're not really adjusting anything on that board. We're not using that board for any logic. All we're doing is feeding raw power in and getting some numbers and observing the smoke. And I'm doing measurements of the resistance of the thermistor so that the controller, when we set up our control device, he can have a table of resistance, and that relates to actions. And we had a bunch of studies going on. This is the schematic for where I am with this particular test. And here's some other study information that was going on over the last few days. And I've got other tables and charts marked up, getting this ready for a controlled, closed-loop controlled environment. And we're feeling pretty excited about it. I think we're going to have a lot of good smoke, a lot of good chuff, and we're going to start building that controller today, I think, real soon. Tomorrow for sure. And we'll keep you informed. But the new smoke housing is really, really good. Feels good to us. Feels good to me. Good to you, good to me. Up the hill. Is anybody in the Army? There you go. Now, what you'll know is at 5 volts, we're not going to get the smoke out of the 17 volt of the flyer. Then one thing, the flyer was all metal, and it was burning a lot of amp power. What we're trying to do is minimize the power required for the smoke, so it just is controlled, consistent, and still fun. Right? You see it, and when we have the sounds, you'll hear them and all that good stuff. So this is where we're at. What I've been doing for the last 4 days, just about. I've got handfuls of these housings that I've built, tested and gone through and made changes and modified and blah blah blah. And there's another piece of work I was putting together, and I think we're close. We're there, and we're going to button this thing up and build a controller. I'll get back to you when I have that. That'll be more exciting, I think, for you than me pushing a button saying, "Oh, there's Puff." Okay, later, gang.